Anonymous methods. The methods we have used so far have been class methods, but we can also use anonymous methods. This powerful feature of C# allows us to dynamically pass and assign methods using delegates. With a delegate object is created that holds a reference to the method that will be called. We create this delegate in a present parent class and then assign the delegate's reference to anonymous methods in subclasses of the parent class. This way, we can dynamically assign a block of code in a subclass to the delegate instead of overriding the parent class method. To demonstrate how to use delegates and anonymous methods, we can build on the classes we have already created. Assigning a delegate to a method. Let's update the public servant class to use a delegate for the method drive to place of interest, as shown in listing 1-9. In the previous public servant class, we needed to override the drive to place of interest method if we wanted to change it. In the new public servant class, drive to place of interest is replaced with a delegate and a property that allows us to call and assign drive to place of interest. Now, any classes inheriting from the public servant class will have a delegate they can use to set their own anonymous method for drive to place of interest. Instead of having to override the method within each class, because they inherit from public servant, we'll need to update our firefighter and police officer class constructors accordingly. Updating the firefighter class. We'll update the firefighter class first with new delegate property, the constructor, shown in listing 1-10, is the only change we make. The firefighter class using the delegate for the drive to place of interest method. In the new firefighter class constructor, we assign the name and age like we did before. Next, we create the anonymous method and assign it to the drive to place of interest delegate property using the plus equal operator, so that calling drive to place of interest will call the anonymous method. This anonymous method prints driving the fire truck and then runs the empty method from the original class. This way we can add the customized code we want to each method with a class without having to override it. Creating optional arguments. The police officer class requires a similar change. We update the constructor as shown in listing 1-11. Because we are already updating this class, we can also change it to use an optional argument, which is a parameter in a constructor that does not have to be included when a new instance is created. We'll create two anonymous methods and use an optional argument to determine which method to assign to the delegate. In the new police officer constructor, we set the new and age, name and age properties as we did originally. This time, however, we also use an optional third argument to assign the has emergency property. This third argument is optional because it does not need to be specified. It has a default value false when the constructor is provided with only the first two arguments. We then set the drive to place of interest delegate properly with a new anonymous method, depending on whether has emergency is true. Updating the main method. With the new constructors, we can run an updated main method that is almost identical to the first. It's detailed in listing 1-12. The only differences are in the last three lines, which demonstrate creating a new police officer who has an emergency. The third argument to the constructor is true, as opposed to Jane Hope, who has none. We then call drive to place of interest on the John Fowler officer. Running the updated main method. Running the new method shows how creating two police officer classes, one with an emergency and one without, will print two different things as demonstrated in listing 1-13. As you can see, creating a police officer class with an emergency causes the officer to drive with the siren on. Jane Hope, on the other hand, can drive without her siren on because she has no emergency. Integrating with native libraries. Finally, something you need to use libraries that available only in standard operating system libraries such as libc on Linux and user32.dll on Windows. If you plan to use code in a library that was written in C, C++ or another language that gets compiled down to native assembly, C# makes working with these native libraries very easy, and we will use this technique in chapter 4 when making cross-platform Metasploit payloads. This feature is called platform invoke or p/invoke for short. Programmers often need to use native libraries because they're faster than virtual machines such as used by .NET or Java. Programmers such as financial or scientific professions who use code to do heavy math might write the code that they need to be fast in C. For example, code for interfacing directly with hardware, but use C# to handle code that requires less speed. Listing 1-14 shows a simple application that uses pinvoke to call the standard C function printf in Linux, or to pop up a message box using user32.dll on Windows. This example looks more complex than it is. We first declare two functions that will be looked up externally in different libraries. We do this using DLL import attribute. Attributes allow you to add extra information to methods or classes, class properties, and so on. That is used at runtime by .NET or Mono virtual machine. In our case, the DLL import attribute tells the runtime to look up the method we are declaring in another DLL, instead of expecting us to write it. We also declare the exact function names and parameters the functions expect. For Windows, we use the message box function, which expects a few parameters such as the title of the pop-up and the text to be displayed. For Linux, printf function expects a string to print. Both of these functions are looked up at runtime, which means we compile this on any system because the function is the external library, isn't looked for until the program is running and the function is called. This lets us compile the application on any operating system, regardless of whether that system has either or both libraries.
It's not here.
With our native functions declared, we can write a quick main method that checks the current operating system with an if statement using OS platform. The platform property we use maps to the platform ID enumeration, which stores the available operating systems that the program could be running on. Using the platform ID enumeration, we can test whether we are on Windows and then call the respective method, either message box on Windows or printf on Unix. This application, when compiled, can be run on either Windows machine or Linux machine, no matter what operating system compiled it. Conclusion. The C# language has many modern features that make it a great language for complex data and applications. We have only scratched the surface of some of the more powerful features like anonymous methods and pinvoke. You'll become intimate with the concepts of classes and interfaces as well as many other advanced features in the chapters to come. In addition, you'll learn about many more of the core classes available to you, such as HTTP and TCP clients and much more. As we develop our own custom security tools through this book, you will also learn about general programming patterns, which are useful conventions for creating classes that make building on them easy and fast. Good examples of programming patterns are used in chapter 5 and 11, where we interface with APIs and ARPCs of third-party tools such as Nessus and Metasploit. By the end of this book, we will have covered how C# can be used for every security practitioner's job, from the security analyst to the engineer, and even the hobbyist researcher at home. C# is a beautiful and powerful language, and with close cross-platform support from Mono, bringing C# to phones and embedded devices, it is just as capable and usable as Java and other alternatives.